Hello, and welcome to this GPX tutorial series recording. Today I'm going to talk to you about how to create a GPX project in the legacy version of GastroPlus. So the first thing to note that is, although GPX is not back compatible, in that it isn't possible to open a GPX project in a legacy version of GastroPlus, it is possible to easily recreate that project in the legacy version. Given the linear logical workflow used in GPX, it is recommended to move through the views and panels in GPX and transfer the information into the legacy database, rather than to try and move through the tabs in the legacy database and then skip around in GPX to find those inputs. The aim is to create one record in a legacy database for each simulation of interest that's in the GPX project. And once a record has been completed in the legacy database, this can then be copied each time the same compound asset is used for a different simulation in GPX. So we recommend starting by reviewing the assets that are used in a specific simulation in the simulation view. You can then move down the nav bar from observed data through to simulations to ensure the replication of the GPX project in the legacy database. When you return to the simulations view, you can synchronize the settings with that legacy database record, and the information in observed data, dosing, physiologies, pharmacokinetics, and physiology schedules should be entered into the appropriate record when it is used in the simulation in GPX. So to try and bring this to life, we're going to use the GPX library that is shipped as part of the GPX install. As you may know, this project contains several simulations for different compounds, and we're going to concentrate on two of them. Firstly, piroxicam. So the first thing we need to do is create a new drug database within the legacy version of GastroPlus. I'm using GP 9.9 because then we're using the same version of ADMET Predictor to import the compounds in both GPX and GastroPlus. So I've already prepared an SD file that contains all of the compounds in the project library. So I can simply select that. We can see that we're using compartmental models, so we don't need to change the default PK model selection. And we're using generally tablet as our dose form. So we'll start by importing a tablet. We'll also use the predicted liver microsome clearance as a placeholder because most likely that's one of the things that will change when you update the properties. So as I've said, using GastroPlus 9.9 means that any properties that are simply predicted by ADMET Predictor will be comparable between the two versions of your database and project. If you use an earlier version of GastroPlus, the ADMET Predictor it uses will be different, and therefore you may have to look at those predicted properties as well as any properties that you've updated for your simulations. So if we'll delete the new drug record, and then we have all of the compounds that we've imported. So we'll jump to piroxicam and start to recreate this simulation in the VB version of GastroPlus. So first of all, we know we're using a capsule. So let's select the capsule as the dose form. And we also know that the dose is 20 milligrams. Now, obviously, we're assuming that we've named our dose schedule correctly, but we can go back and check as we move down the nav bar later. We're using a compartmental model, and our physiology schedule appears to suggest that the body weight is 78 kilograms. So let's update that as well. If we move on through into the compound settings, you can see that we're using a one compartment model, which is reflected in what we've imported from ADMET Predictor. The liver first pass extraction is turned on, so we need to make sure that volume is entered here. The nanoparticle effect is on, and it's the default value, so that should be fine in VB. And the bile salt effect is also used, so we need to check that as well. So the solubilization ratio is 7.08 to 4, which is correct. This number does vary, so it looks like other properties that impact the calculation of this solubility will be updated. So that's why, or that's one of the reasons why we suggest starting and finishing on the simulations view, because as you update things down the navigation bar, you will find that these should hopefully come into line. The dissolution model is Johnson, which is the GastroPlus default, and the precipitation time is 900 seconds with the constant particle growth with the initial radius of 1. So again, all default. Permeability, however, you may need to check. So if we cancel out of here and look at the permeability, so that has the right source. However, the values are different. So we'll need to revisit this once we've completed the compound tab. And the ACAT model, again, we're using the default settings for that and observed data. So we do have some observed data with this simulation. We have a CP time profile, but we also have some parameters. So we will need to bear that in mind when we move through to the observed data in a minute. And in terms of the configuration, the rest tend to be a GPX specific setting, but the simulation time is obviously longer at 240 hours. So let's update that now. So if we jump up now to the observed data, you can see that we have piroxicam CP time profile and also a piroxicam solubility profile. So let's start with the exposure. So we've got the piroxicam exposure data here. We can't copy out of this table, but you can copy from the graph. So if you right click and then select copy data to clipboard, you can paste it into Excel and then copy it out and into an OPD file. Check the units are the same, enter the dose and the body weight. And then just for completeness, maybe consider going to the lab book and see whether any notes have been put with this particular profile. So here we have a reference for the publication that the data came from. So again, you may wish to add this into your OPD file before you can save it and move on to the SPD file. So to view the SPD or the solubility data, switch to solubility, check that the right group name is selected, and then copy the data again to paste into Excel. You can't paste directly from GPX into VB. Okay, let's find our load the SPD file, paste, check the units. This time they're incorrect, so we will need to update those, redraw, and then again, go to the lab book, look for your solubility, and then take any notes that you wish to keep in your VB database before saving. The other thing we noticed was that we had some parameters. So they can be viewed in this table here. So we've got 100% FA and 100% bioavailability. So navigate to the correct place in your legacy database and type in 100% F and 100% FA. And I'll just save the drug record at this point. So that's the first view completed within GPX. So now we need to start looking through the other views. So again, always check as you move between the views that your compound is the one that you want, and then start to double check. So we do have the right molecular weight, so that's always reassuring, and the correct diffusion coefficient. We don't have a melting point, so that can stay as 0. Looking at the solubility, we do need to make some changes here. So the pH is 3.5 and the solubility is 5.9 to the -3. The temperature is 25. So let's open up the right view to have a look at that. You can see that that is the same. The density is 1.2, which you can also see here. And then the interfacial tension is 0.019, which is obviously come from ADMET Predictor. So that all appears okay. The biorelevant solubilities can come next. And here we can see the values looking across are the same. So that's also means no changes are needed. And then on to the pKa's. We cancel out of here and open up the pKa. We've got 10.83. So all those values seem to be fine. And then we have the log P. So here we do need to just update it to 1.98 and then open up the pKa table again to have a look at the models that we use. So the model is structural, so that's fine. And the plot looks to be correct. The one thing I should have said when we went back to the pKa was that you can select the group name, and you can see that the ProxCam measured solubility data is shown in the black squares, and that fits reasonably well with the profile that we see on the screen. So we can just do that same visual check in VB, that we haven't made any mistakes in terms of typos as we've been entering this data. But again, it aligns quite nicely, so that looks to be fine. So moving on, we've got the permeability, which we've already had a hint may be slightly different, and indeed it is. This is one where the units are different. So here the units are centimetres per second times 10 to the minus 4, whereas here they're just centimetres per second. So you do need to make sure that you consider this as you're entering this permeability data. In terms of Adson and Zimin, so we've got the Zimin selected here, so that's fine. And we'll double check this when we get back to the simulation settings in a minute. We have no enzyme kinetics and no transporter kinetics. So now we're ready to move on to the dosing view. So the first thing we need to do is to confirm the dosing schedule that we use in the simulation. So we have the 20 mg oral capsule, 25 micron dosing schedule. So if we select that here, we can see we use the oral capsule 25 milligram formulation. Now we know we're looking at the correct assets in GPX. So we've already updated our capsule, and we can see the mean radius is 25 with a standard deviation of 0. So again, we just want to double check that that's also consistent. For this particular one, we don't need to worry about the distribution type, which you can see here, because we don't have any standard deviations and we only have one bin. But we do want to just scroll down and check the shape factor, and that ties up nicely. The particle density, you can see on the front tab, and then the diffusion layer, you have to open up your dissolution model window to see that the diffusion layer is set to variable with a maximum thickness of 30. So that all seems to be correct. To finish this view, we'll just double check the dosing schedule. So 20 is our dose, 120 is our dose volume, and it's just one administration. So that is reflected here. So now we can move on to the physiology. However, when we check the simulation, it's the physiology schedule that's listed. So first of all, we do need to jump to the physiology schedule and check which physiologies are used in that schedule. So we have 78 kilogram human fasted physiology schedule. So if we switch to that one, we can see it's a very straightforward schedule. We just have one physiology used throughout the simulation, and it's the 78 kilogram human fasted physiology. So ensuring that this is selected, we can now double check the settings. So as we thought, the body weight was 78, so we've already updated that. We know we don't have a PK model, so we can ignore the pair panel and move down into the gastrointestinal panel. I have to say this is easier when you use two screens. There's not quite as much jumping about. So as we saw, we're using the default ASF model, and that is reflected in the legacy database. The default % fluid in the small intestine, a fasted model, and 0 order gastric emptying. So that all appears to be as we would expect. We can now scroll down to the table, check the ASF, and also check across the table, because here you'll find your fraction unbound and enterocytes, your pH, etc., and your transit time. So this is important, especially for those dose formulations that trigger the warning about maybe considering a shorter stomach transit time. For this, you can see GPX is using 0.25. So when we run the simulation, we must say no to the message that comes up in the VB version asking us if we want to shorten this to 0.1 hour. So that is something to remember. So check across the table and confirm that all of this matches up prior to moving to the pharmacokinetics view. So for pharmacokinetics, we do have your blood to plasma ratio, which is 0.55, and a measured fraction unbound in plasma of 0.7. And again, just double checking the adjusted plasma FUP allows you to make sure you've made no typos for the log P or the FUP. Your liver blood flow is shown on the compartmental tab, so you can check that against the gut physiology tab in the VB version. You can see the units are different, so it is easy just to switch the units in GPX so you can compare like with like across the two platforms. Moving back to the pharmacokinetics tab, we need to decrease our clearance. There's no renal clearance, so that's fine. And we also need to decrease our volume. And again, you can just check the calculated half-life, make sure you have no typos. We've considered the physiology schedule, so now we're ready to confirm the simulation settings. So the ones I suggested we come back to were the bile salt effect, which you can see here. And you can see that we've now got 0.077 in both platforms, so that's good. And then the other one is the permeability. And again, now you can see that the converted permeability we're going to use is 6.65 to the -4 centimeters per second, which reflects here. And you can also check that your paracellular and transcellular match between the two platforms, again, being mindful of the units. Okay, so let's run the simulation in GPX. Save the drug record and run the simulation in the legacy, making sure to say no, because we want to use the stomach transit time of 0.25 hours. And if we eyeball the two different plasma concentration versus time curves, we can see that they're broadly similar. Obviously, we can also check the summary view to make sure that the values that we're returning for the summary parameters are within a reasonable values of, as we would expect. So 1876 nanograms per mil for the Cmax and 1.876 micrograms per mil for the Cmax in VB. So they all seem to be reasonably well aligned. There is another way you can check. So for that, I will just do the same exercise, but for carbamazepine. So again, we'll go back up to the top of the simulation view and start to update the values that we see. So carbamazepine is a tablet, but it's a 200 milligram tablet. We're using a 78 kilogram compartmental model. And you can see that here we have first pass extraction in both the intestine and the liver. So we need to make sure to update both of those. I know that the nanoparticle effect, again, we're using the default. The bile salt effect does need to be checked. So let's open up that screen. You can see that the solubilization ratio is 0, so we need to set that to 0 in here. And again, this looks like it will be updated as we progress through the model settings. The dissolution model is default, as is the precipitation. But here we actually have a different model for our permeability. So that is something to switch to here. So we need to switch to the absorption system CACO2 model and then double check the value for that CACO2 permeability when we get onto the compound view. The ACAT settings are default. And for the observed data here, this time we just have parameters, so we will need to go and grab them in a minute. And the simulation length is 24 hours. So we're kind of done with the simulations view for the first pass. So let's go and check the carbamazepine parameters and get those into our database here. So the carbamazepine FA is 99 and the F is 78%. Moving back to the compound view, selecting carbamazepine at the top and double checking that we have the right molecular weight. This time, look, we do have a melting point. So let's go and enter that now. So the melting point here is 192. The diffusion coefficient You can see here at 0.86 centimeters per second times 10 to the -5. So that matches up when you take account the different units. In terms of solubility, again, do we need to make any changes? Yes, we do. So we'll cancel out of here. 6.86 for the pH and 0.15 for the solubility. The density is as per. Let's just check the interfacial tension. Interfacial tension is correct. So the biorelevant solubilities are next. So here we have 0.39, 0.48, 0.17. So they all seem to be okay. So we're done with the solubility panel. Looking at the pKa, we don't have any measured data this time. So we just need to check the actual values for the pKas. Do you make sure you save these changes as you make them, of course. So the pKas are looking comparable. And then the structural model is selected and all the input parameters appear to be correct, but the actual log P of 2.19 does need to be updated. And then the permeability. So we have, well, that's interesting. What have we done now? So it looked like the permeability hadn't refreshed, so do keep an eye out for that. But we've got 5.26 for CACO2, so that times 10 to the -5 because of the units, that's now correct. So hopefully when we move back to the simulation view, our simulated PEF will be comparable. And then if we just check the zoom in properties, again, they seem to be fine. So again, we will come back to those again on the simulations view once we reach there. The enzyme kinetics and the transporter kinetics windows are blank. So moving back to the simulation, you can see our dose schedule is 200 mg oral tablet, 75 micron. So we'll move to that in the dosing schedule. And we're using the oral tablet 75 micron. So again, you can select that here. And just check everything is as you expect. So tablets, 200 milligrams. But this time we need to update the particle size to 75 microns. Again, we only have one bin. So although it says legacy log normal, which does directly compare to the log normal distribution type in BB, that's not impactful for this particular simulation. We have a shape factor of 1. And again, the diffusion layer settings are default. So we can check those, but they should be the same in both platforms. So just double checking the dosing schedule. We have one dose with a dose volume of 250 milliliters. So that all seems to add up. The physiology schedule is again the 78 kilograms. So we may remember from last time that there's just one event and that we use the 78 kilogram human fasted physiology. So as long as our compartmental model uses the 78 kilogram body weight, all of these we saw previously were default. So whilst it's worth just double checking some of the values in the ASF, because this is a reusable asset in GPX, and we didn't change anything for the last record we created in VB, we know that we should be fine for this one as well. It is also worth checking the Fe enterocytes though, because that's a physiomolecular property, and so could vary with compound as well as physiology. Okay, so we're ready to move on to the pharmacokinetics tab. So again, it appears that we've still got a hangover of different blood to plasma ratios, because that, if you remember, was the piroxicam blood to plasma ratio. And so updating it to the carbamazepine blood to plasma ratio and protein binding should allow the lipid adjusted to fall into place. We have a clearance of 3.39. This time we have renal clearance of 0.0168. Again, the units are comparable, and a volume of distribution of 1.51, which gives us a matching half-life. So that's the pharmacokinetic view finished. So we do need to go back and just check the bile salt effect. So if we call up the bile salt window in VB, we can see that the calculated FASIB and FESIB do match up. And the permeability, if we check that, we can see that we have the same paracellular, the same transcellular, and we also have the same converted. So in GPX, the converted PEF is equivalent to the stimulated PEF in VB. Okay, so I think we're good to simulate. So let's simulate in GPX. And this time, let's copy the data from our CP time curve into Excel. And then copy it and create some observed data or an OPD file in VB. That will allow us to easily see whether what we've actually created in VB is the same as in GPX. So let's paste it in, double check the units. We've got hours against nanograms per mil, so we do need to check that. Okay, so that's looking good. Save that. And then we can run, save our drug record, and then run our simulation. And hopefully what we'll see when we navigate to the CP time curve is a nice alignment of the T simulations. So this hopefully gave you a flavor of the best way to set about converting a GPX project into a VB legacy database.